Hi, everybody. Today we are finished with chapters 5 and 9, and we are going to just talk about problem solving for these two chapters and answer any questions that you might have. If you take a look at our Moodle page, you'll see that we have completed and posted the last lecture for chapter 9, which is section 9.2. We're skipping sections 9.3 through 9.6. And then this week we have a problem set for chapter 9 due, and then we have a quiz due before we start working on the next chapter, which is chapter 6. All right, so in other words, we did 5-9. Now we're going to go back to chapter 6 in a couple of days. But no more new material until we get to that point. All right, so chapter 5 dealt with the first moment of inertia, or the first moment. And in the first moment chapter, we did two different skills really. We did finding first moments by direct integration, and we did finding first moments using composite shapes. So then we skipped to chapter 9 because we wanted to do the math that looks really similar to that, and we did the moments of inertia, which is also sometimes called the second moment or the moment of the moment, and we discussed how to find those, first using direct integration and then using composite shapes. Somewhere in that mix, we also talked about surface areas and volumes of rotation based upon the location of X bar and Y bar of different shapes. So our homework has been, they're complicated, long problems, but we don't have a bunch of homework problems. From our submission, we have problems 9.10, 13, 15, 17, then 32, 34, and 41. And from chapter 5, which will also be on this quiz, we had a few more problems, there being a list. So my question to you is, do you have any questions about the homework or anything I can help you with? And if not, if you don't have anything today, I'm not going anywhere, so you're certainly welcome to come by my office as well. And everybody here does that really routinely, so I appreciate it.
For chapter 9,
yeah.
Where, on the first one, it's 9.10.
Okay, let me get to it.
When you use the diagram...
I'm sorry, I'm still getting back to chapter 9. So 9 point... I'm getting close. 9.10. Okay. 9.10, when you use the diagram.
Yeah, what's the difference between how would the answers differ between 9.9, 9.10, 9.11 if you're using the same diagram?
Okay.
For each of them? Right.
So if we come over here and we look at the document cam of those problems, and you're looking at 9.10 and 9.13 in this case. 9.9 asks you to determine by direct integration the moment of inertia of the shaded area with respect to the x-axis. So in other words, we're talking about an I sub x value, and then it says for 9.13, determine it with respect to the y-axis. So it would be going in the opposite direction. Would you like me to work those out for you so you can have an example?
Well, I was wondering more. It says 9.9 through 9.11.
Oh, right.
So like
9.9 deals with this diagram. 9.10 deals with this diagram, and 9.11 deals with this diagram.
Oh.
And then you just go back to the same diagram for 12 to get your rotation about the y-axis, and similarly. So you use 3 diagrams. This is used for 2 problems. They could have made it 1 problem by saying find the moment of inertia with respect to the x-axis and respect to the y-axis. And you have 2 answers for 1 problem.
Okay.
Does that help?
Yeah.
Okay. You guys are going to take it easy on me today, I can tell. Do you have any other questions?
Can we do an example with
Yes.
with the, look at this item real quick.
Sure.
In the last section of chapter 5 with the,
Distributed or?
yeah, the.
Okay. Yep. Give me a problem you would like me to work, and I'll be happy to do it.
Could we do like 104?
Yep, absolutely. 5104. Yes. Okay. Yeah, this is an excellent problem, isn't it? So, all right. So let's take a look at 104. And I'll put this up on my document cam to begin with. Okay. And when we talk about 104, we're talking about the machine element shown. Locate the y coordinate of the center of gravity. All right. So in other words, we have a fully three-dimensional shape, but all that we're asking for is that y component. All right. All right. Okay. All right. So if you look at this particular problem, the first thing that we have to do is to assume that it's homogeneous. In other words, we need to make an assumption that everything has the same thickness. And so then we're just going to have to use, we can use the idea that the centroid is going to be the same as the center of gravity. Okay? And so if we consider it that way, and we look at the y-axis as being up, okay? Let's go ahead and break this down into parts, all right? So
from the graph
yes.
that we have so far,
Yes.
you have the y components going upwards, the
Yes.
x components going out to the diagram looks to the right, and then the z would be coming towards you. Would the z component just be the halfway point?
It's symmetrical, isn't it?
Yeah.
Yep. So if you look at it that way, I'm just thinking about it, just want to make sure. Yep, everything is symmetrical. So in the y-axis, in the y direction, the problem is that we have, I'm just going to draw this kind of two-dimensionally. We have this piece below the x or below the y-axis, don't we? And then we have another piece that's flush with the y-axis, but then there's a little knob sticking up, right? So those are sort of the ideas that I would play with here. So I would probably look at this as being 1, 2, 3, 4. One, two, three, 4 pieces. Okay. I would call this. Did you break it down into more than that, or did you do 4? Okay. Because I was looking at.
If you took the center of your square, it's going to be the center of that circle, assuming this circle that's cut out.
Is it symmetrical? Right. But we still, because it's a composite shape, we have to think about it being up. This plate, if we drew it, like if y is up, let's do this. I need to be a little bit more rigorous. Okay, here's y. Let me just do it here. this plate is going to have a thickness, okay? So in other words, I've drawn this kind of in a weird plane. But if we draw this in the y plane, I want to go back to this original diagram. Okay. Okay, yeah, this plate is going to go down in the y direction, right? So we have y and x right here, right? Then this plate in the y direction, this has this shape, but basically it goes up. So here's my y-axis, and here's my x-axis. But basically, what I'm trying to see, I have that coming out actually at the bottom. Okay, so I'm good with that. And so then that means that's right at the top. So this piece just hooks onto this is what's going on. Okay, so I just want to make sure I had the right picture because I kind of drew it and then I was like, wait a second, I'm not really sure. Okay, so I would do this using composite areas, and the first thing I would do is I would find that volume. And what units am I in? I'm in millimeters, so this is going to be in millimeters cubed. And then all I'm really interested in is the y component, so I don't really have to do all of my other chunks. All right, so all I have to think about then is the volume and then my y bar component of each of those, and that's going to be in millimeters. And then I'm going to have my yi vi, which is going to be in millimeters to the fourth, right? And then I just need to sum this up and sum this up. I don't know why I put these down here, because I need to do my calculations here. So let me just expand this out. And then my volume, this is the summation of the volumes, okay? So then I can just take summation yi vi divided by the summation of the vi's, and I will get my yi of the composite shape. All right, so having said that, when we look at this rectangle, it is 100 millimeters in this dimension and 120 in this. So this is 100 times 120.
So is that, are we just finding the surface area?
No, then times the thickness, which is 10. So that's 120,000 millimeters to the third. Okay. See, I would rather call this number 2 because it's kind of like here, and then let's call this 3 and 4. Okay, just to keep my two pieces together. Then this is the volume of a circle, but it's cut out, right? So what that means for us is that it's going to be a negative. So that's pi times r squared, which I'm told that's 30 millimeters.
And that times 10.
Exactly. So 30 times 30 times 10 times pi. And that turns out to be negative 28,274. Okay. Then part 3, which I'm calling that little circular knob, has a radius of 40. So that's going to be pi times 40 squared, and that is also 10 deep. So that circular, the knob on the top is 50, 265.6. And the fourth plate, all right, so that is part 4, looks like this, right? And it's solid. I mean, yeah, it says it's a 10, it says it has 10 millimeters, so the whole thing is solid. So basically we have a half circle up here, and we're told that that distance.
So would you need 5 parts on that?
Yeah, that's what I'm wondering.
Find the rectangle, area of the rectangle along with the area of the half circle, and then add those together to get your total.
Yes. That is definitely what I should have done. So 5. I was thinking I could do a formula for this, but no, you're right. We need to have a rectangle, which is this. This is 4. And so this is going to be 5. Okay? So 4 is going to be 60 times, oh, there it is, 120, right? Times 10. Yep, 60 times 120 times 10. And then the other part I'm trying to see is, okay, so the diameter of that half circle is 120. So that's going to be pi, we can say 120 squared, but it's diameter, so we have to divide that by 4 times 10. Okay, and those are both positive. So yay, we're ready to go. So we do need 5. Yep.
Can we do the radius squared?
Yes.
So it'd be 60 squared?
Oh, absolutely. If you want to get rid of that, just put 60 here. Like that? Yep. All right. So then this piece is 60 times 120 times 10. So that one is 72,000. And this one is 60 squared times pi times 10. So this is 113,097.6. And when I add all of those together, subtracting that one, I get a summation. My total volume is 327,089.2. All right.
So for 5, which is going to be semicircle, right?
Half circle. Oh, so I need to divide that by 2.
Yeah.
Thank you. Yeah, so let's do that. That would be better. Minus parentheses 113,097.6 divided by 2 parentheses equals. So then that comes out to be, I get 270,540.4.
Well, we have to.
I don't know if I got that right or not. I feel like, let me do this again. So if I have a 60, yeah, so it's a half circle, so we have to divide that by 2, but it's 60 squared times 10 times pi divided by 2. So I get, this number would be 56,548.8. Okay, add that to 72,000 and add that to 50,265.6 and subtract from that 28,274 and add 120,000. I get 270,540.4. I feel like there's a big high chance of having an arithmetic error in there. All right, so let's take a look at our y bars. That's actually going to be a little easier, isn't it? Part 1 goes below the x-axis, and it's 50 millimeters, so it's a negative. That circle is centered, so it's also at negative 50. Part 3, which is the knob on top, is 10 meters up plus, or 10 millimeters up plus half of the thickness, 5. So that's going to be at a positive 15, right? And then the flat plate and the semicircle are both going to be halfway up, so 5 and 5. So far, so good?
So our centroid thing for number 3, which is our plate, our circular plate sitting on top. So that one, is that 5 coming because we're taking the center of our disc?
Yes. And it's sitting on top of the 10 millimeter thick disc, so it's 10 plus the center, which is 5. Yeah, absolutely. All right. So if I add all those together, or if I'll multiply that, 120,000 times 50 negative is negative 6 million. It's a lot of millions, huh? A lot of numbers. So then we have negative 28. Let's see, this is going to be really interesting. 274 times a negative 50, so that becomes a positive, doesn't it? Becomes a positive 141,370. Okay. Then we have 50,265 times 15, which is 753,975. 5 times 72,000 equals 360,000. And last but not least, 548.8 times 5 gives me a value of 282,744. So I only have one negative number in this column, and I add those together, including that negative number. Minus the 6 million. Yeah, that can't be right. I got too many zeros. See how that is? I'm going to just, let me see this here. I feel like there's an error. Well, it could be. Okay. I'm going to write down my first number and see if I get the same one. Minus 3189581. All right, now I'm going to try again. I'm going to do millions, so I get minus 6 plus 1.4137 plus 0.753975 plus 0.360 plus 0.282744. Okay, yep, 3189584. Okay. So then I take this number and divide it by this number, and it's negative because it's below, which makes sense when you look at the picture. It's below the y-axis because this plate carries quite a bit of that mass, and it's below. So there we go. Over the volume, which is 270,540, and so that value comes out to be negative 11.8, and that would be in millimeters. Okay, so what that means is if we look at our original picture, which you can't really see on here because of my reflective sunlight, I know. Tamiki, can you turn that? Or oh, here's Isaac. He's got it actually easier. You're closer, but he's his walk is shorter. That looks better. There we go. Thank you so much. All right. So what that means is our y bar is somewhere in here, which makes sense because we have quite a bit below here. This is off to the side, so there's quite a bit of mass. But there's also a lot of distance, so it makes sense that that would be below the y-axis, or below the xz plane.
So that negative 11.78.
Mm-hmm.
So that
Yes, that is correct.
Distance from our 0.00 down.
Yes.
That's where our centroid will be for the y-bar.
Yes, that is correct. Now wait, I have to. Okay, if you look at where I defined my x, you know, I see a little issue here. If I define my 0 as being here, that's at the top of the bar, but that also means that this one is going to be below. Do you see that? So it's going to be like at a negative 5. So that these two, the bottom two, would be at negative 5. I've kind of used it both ways. It's thick, but I used part of it at the top of the plate and part of it at the bottom of the plate. So, and actually, to tell you the truth, we'd need to take out 10 millimeters here, wouldn't we? In other words, because of the way they hook up together. If you look at it, if I turn this sideways, this is what it looks like. So if this is 60, or 100, sorry, coming down, if this is my z-axis, then this is slightly above, but that means that I have to call this one 90 instead of 100. Yeah. That's an interesting little problem. That's a good problem, but it's, yeah, I misdefined the axis, so I would actually have to change one of those, because I've counted this little chunk right here. I've counted that twice, essentially. So I need to eliminate it from one of those calculations. So in other words, the easiest thing for me to see would be if I keep it here, that means that I need to make this distance, that rectangle, instead of being 120 by 60, it would be 120 by 50. Yep. So that's probably a little bit off. So when I look at this number of minus 11, it's not correct, but the question would become, is it from the bottom of the plate or the top of the plate? And when I have it done, it's incorrectly done from the top of the plate because I've counted this little chunk twice. But it really is more like it's from the top of the plate. So you can see why you only have a few problems. They're sort of complicated. So, all right. Do you guys have any other questions? All right, well, that's it for today then, gentlemen. So if we go back and take a look at our Moodle page, I will post this as Lecture 24A. I'll just state it as a problem-solving session. And then your homework, I have that it's due today, but really if you turn it in, by Friday or even by Monday of next week, it will be fine. Monday of next week, though, we're going to start on the new materials, so try to get it done, but I won't. The same rules apply. Late homework still counts full, so don't worry about it, all right? Just do it before you take your quiz, so you're ready for your quiz. All right, and the quiz is timed. It's exactly, the process is exactly the same as last time. The only difference is instead of taking a picture of your work and sending it to me, you can just hit this button, take a picture, and submit it as a PDF or whatever. All you guys are submitting just fine. So however you submit your homework, you can submit it here as well. But do that right after you take the quiz, like that minute. Okay? All right, well, you guys have a great day, and we'll see you maybe Friday. We'll be grading your quizzes, and we'll see you Monday, guys.